Okay, so I think I am audible to you and my screen is visible to you, right?
Yeah.
Okay, so yesterday I shared some documents which are going to be supplied to you as a supplement during the examination. So I inquired with the examination section. Even they are providing a data book which is only old edition. It's not a new edition. They are giving you only the old edition. So what I have with me, the same thing they are giving. So these tables, whatever I forwarded in that WhatsApp group, so those are given as some Xerox sheets. So which are pinned to your design data book. So that's why I ask you go through all those things. What we'll do is, so with that, what is the data he has given in the additional sheets, how we can use those sheets to solve the problems. So we already solved some problems on this design of Spur gears. We'll revisit those problems. So with the data given in this problem are given in the data book. So in the formulas given in there is a supplement as a your data book. So how we can use those supplements and how we can solve the problem. So same problem. We'll discuss that now. Later on, if time is there, we'll see. We'll move to the next topic. Maybe today we'll close this helical spur gears. Tomorrow we will go for helical gears. In the afternoon, I think we have a fifth hour, right? OR. Afternoon fifth hour OR kada. Fifth hour ఏంటమ్మా మీకు ఆఫ్టర్నూన్ ఈరోజు? So I'll take that class also. I think OR syllabus అయిపోయిందండి కదా. ఎందుకంటే సార్ ఇచ్చే క్లాస్ నాకు అవసరం లేదు సార్ అని నాకు ఇచ్చారు. సో విల్ ట్రై టు కంప్లీట్ యాజ్ ఎర్లీ యాజ్ పాసిబుల్ అవర్ సిలబస్ ఆల్సో. మీ ఎగ్జామ్ స్టార్ట్ అయినా లేకపోయినా సో ఫస్ట్ సిలబస్ కంప్లీట్ చేస్తే దెన్ ఇఫ్ హ్యావ్ ఎ టైమ్ దెన్ యూ కెన్ review or prepare for that. Okay, so fifth hour also I'll take. Again, what we'll do is we'll try to solve the problems with this data book. So now we cannot say you don't have any data book or something like that. So I already posted that thing in the WhatsApp group. So just use that and try to solve the problems. So today we'll even this class and the afternoon class also we'll do that, so that you will get familiar with spur gears, and also it is easy to get the marks in the examination also. Definitely you will get a one question, so you can easily solve the problem with these formulas what he has given in the data book, and you can easily score the marks also. So that's why I allotted these 2 hours for this again revisiting these problems what we already discussed. Okay, so in that, okay, first let me show you what I shared yesterday. These are some, not all the data, only some of the data. One table what I shared it here is, let me go back. Yes, this table, this one. I think this is not there in a data book. So even కొత్త data book లో కూడా ఇది లేదు. ఈ టేబుల్ ఉందా? I think somebody has messaged me saying that entire data what I shared is available in the new edition of the data book. So ఈ table ఉందా data book లో? That is Lewis form factor. మనం ఏదైతే ప్రాబ్లమ్స్ లో డిస్కస్ చేసామో క్యాపిటల్ Y. సో క్యాపిటల్ Y ఫార్ములా వాల్యూస్ ఇవన్నీ. సో అంతకుముందు టేబుల్లో మనం చూసింది ఏంటంటే ఇట్ ఇంక్లూడ్స్ కాస్ ఆల్ఫా అనేది ఇచ్చాడు. అది కాదు, అది కాకుండా ఈ టేబుల్ ఉందా? Those who are having a new data book, you tell me that, or else what you do is you don't bother anyway. You are not going to bring that one to your examination section. So only people will provide the examination in the examination only the old edition only. So then, so this table will be supplemented supplied as a supplement. So దీంట్లో ఈ టేబుల్లో ఏం ఇచ్చాడంటే క్లియర్లీ మనం ఎక్కడ ఎత్తుకోవాలి. జస్ట్ ఇఫ్ యు నో ద నంబర్ ఆఫ్ టీత్ for 3 different kinds of different types of teeth, that is 14.5 degrees Ferrari angle full depth teeth, 20 degrees full depth teeth, and 20 degrees soft teeth. So this is also same column. Only thing is this is the number of columns are increasing. So from 10 to 35 is given in this column from 37 to 200, and for rack it is going to be radius is going to be infinity, so you can take infinite number of teeth or something like that. So he has given the Lewis form factor for all these things. So let us say in one problem we solved for 18 number of teeth. That is the first problem. In 18 number of teeth and 20-degree full depth teeth, so y is going to be 0.308. So exactly the same what we have taken from the textbook. Even in the Bandari textbook also has given the same thing. So if you want to choose the Lewis form factor, then you have to use only this table, not the table given in our data book. So అంతకుముందు ఏదో డిస్కస్ చేసాం మనం, y cos alpha కూడా ఇంక్లూడ్ అయింది, అక్కడ వాల్యూ తీసుకొని ఆ వాల్యూని cos alpha తో డివైడ్ చేసి you take the y value like that we discussed it. But now don't follow that. So just use this table. So from straight away from this table you can take the capital Y. So then your bending stress beam strength is nothing but beam bending strength is nothing but SB, which is nothing but the formula what we are using here is M into B into sigma B into Y. So this is the formula. In this formula, straight away this Y value is you need to pick from this table. So provided you should know what are the number of teeth on the pinion or gear, whichever is going to be the weaker for the design. So
slide change avutలేదు సార్.
స్లైడ్
మీరు ఇందాక టేబుల్ అన్నారు కదా సార్,
టేబుల్ కనిపిస్తుంది మీకు?
లేదు సార్, 48 పేజ్ లో ఉన్నాం.
Okay, then okay, I'll do it. Maybe sharing, there is some problem with the sharing. Okay, now it is visible, the table?
Yes sir.
ఈ టేబుల్ మీ డేటా బుక్ లో ఉందా? ఫస్ట్ ఆఫ్ ఆల్ లెట్ మీ నో దట్. I think it is not available in the data book. So
data book lo ఉంది సార్.
కొత్త డేటా బుక్ లో ఉందా మీది?
ఎస్ సార్ ఆ టేబుల్ నెంబర్ కూడా సేమే సార్. కొత్త డేటా బుక్ లో వాళ్ళు జిరాక్స్ తీసినట్టున్నారు సార్.
అవునా? 28.33 అని ఉందా? ఇది ఉందా?
ఎస్ సార్.
ఈ వాల్యూస్ అన్ని ఉన్నాయా?
ఎస్ సార్.
మరి లాస్ట్ టైం నేను అడిగినప్పుడు చెప్పలేదురా y ఫార్మ్ ఫ్యాక్టర్ అని, మనం ఏదో cos alpha అని వర్కర్ అని సొల్యూషన్ ఏదో బయట y ఇంక్లూడ్స్ cos alpha అనుకోని కూడా నెంబర్ ఆఫ్ టీత్ ఒక టేబుల్ నుంచి నెంబర్ ఆఫ్ టీత్ తీసుకొని దాన్ని cos alpha పెట్టి డివైడ్ చేసి దాని నుంచి y తీసుకొని చేసాం కదా.
అది వేరే టేబుల్ ఉంది సార్. మళ్ళీ అది
కూడా ఉందా?
రెండు ఉన్నాయి సార్. ఇది లాస్ట్ లో ఇచ్చారు సార్, ఇది అదేమో స్టార్టింగ్ లోనే ఉంది.
అవునా? ఓకే. సో ఇంకోటి ఏంటంటే నేను చెప్పేది ఏంటంటే మీరు న్యూ బుక్ లో ఇచ్చారు, మేబీ దాని నుంచి తీసుకొని ఉంటారు వీళ్ళు. ఇంకోటి ఏంటంటే మీకు ఎగ్జామినేషన్ ఇచ్చేది న్యూ బుక్ కాదు, ఇది ఓల్డ్ ఎడిషన్. నేను ఒక బుక్ తీసుకొచ్చే ఎగ్జామ్ సెక్షన్ నుంచి నిన్న, దాంట్లో కూడా లేవు, అందుకనే దానికి సప్లిమెంట్ లాగా ఇస్తాను వీళ్ళు. ఓకే, సో మీకు ఇది కనుక తెలిస్తే ఈ టేబుల్ కనుక ఉంటే డైరెక్ట్లీ యూ కెన్ టేక్ దిస్. ఈ టేబుల్ నుంచి మీకు 14.5 degrees ప్రెజర్ యాంగిల్ ఫుల్ డెప్త్ టీత్, 20 degrees ప్రెజర్ యాంగిల్ ఫుల్ డెప్త్, 20 degrees స్టబ్ టీత్. సో వీటన్నిటికీ మీకు జెడ్ నంబర్ ఆఫ్ టీత్ తెలిసిందంటే డైరెక్ట్లీ యూ కెన్ టేక్ ద వాల్యూ ఆఫ్ Lewis form factor y. So capital, what is the capital Y? So we are using the formula SB is equal to m small m into b into sigma v into capital Y. So this is the formula using. సో ఇంకో కన్ఫ్యూజన్ ఉంది. వేరే బుక్ రెఫర్ చేస్తే అంటే ఈ వైని వాడు ఇంకేం తీసుకుంటాడు, ఇలా తీసుకుంటాడు. స్మాల్ వై అని రాస్తాడు, మనం క్యాపిటల్ వై రాసాను ఇక్కడ. సో వాడు స్మాల్ వై రాస్తాడు, స్మాల్ వై ఈజ్ ఈక్వల్ టు క్యాపిటల్ వై డివైడెడ్ బై పై అని ఇచ్చాడు. సో అది తీసుకుంటే అది ఫాలో అవ్వాలి. అది అక్కర్లేదు, మనకి నెంబర్ ఆఫ్ టీత్ తెలిసిందంటే స్ట్రైట్ అవే ఏం తీసుకుంటారంటే యూ కెన్ యూజ్ దిస్ టు చూజ్ దిస్ క్యాపిటల్ వై వాల్యూ. సో దట్ మీన్స్ ఇఫ్ యూ వాంట్ టు క్యాలిక్యులేట్ ద బెండింగ్ స్ట్రెంత్, మాడ్యూల్ m b face width, sigma b is nothing but if the allowable stress is given, you take that one as the allowable stress, or if not given, you have to take SUT by 3. Then this capital Y you have to take from this table. So that is the first point I want to clarify here. So in one of the problem we solved for 18 degrees. So we taken there 0.308, exactly he has given the same value. For 20 degree full depth teeth, it is for 18 number of teeth, this value is 0.308. So this is one thing. And also now there may be a question. So in some problem we have, I think a second problem or a third problem, we have 90 number of teeth, not 18 or not 20. So in this data table, only as given for 18 teeth it is 0.308, for 90, for 20 teeth it is 0.32. But if your opinion is having 90 number of teeth, then how we can choose the y value? So in that case, what you do is, just you need to interpolate these two values. So 18, 20. So nothing but average of these two. 18 plus 20 divided by 2 is nothing but 19. So in similar manner, you can take these values 0.308 plus 0.32 divided by 2. Average value you can take. So you have here alternate numbers. So you can see that 10 or 12 is there. Suppose if he has given 11, then take the average of these two values. 14, 16 is given. So if the number of teeth, of course, the minimum number of teeth for 20 degrees it is it starts from only 18. So from this point onwards only you can check it. So 24, 26, 28, 30, 32, 33, like that he has given. If anything is, suppose if you have a number of teeth in between, then you have to interpolate that. Here in the difference is only 2 means you can take it as average also. Straight away by taking average also you can find the module. Okay, this is one thing I want to clarify. Then the next table what I extracted is, okay, so I'll show. Okay, even this is also given. This table is also given in our data book. Same thing he has given. Okay, so this is not like this. Maybe in the different format he has given. Steady load, light shock, medium shock, heavy shock, something like that he has given. And type of service, so that is how much time it is operated, 3 hours per day, 8 to 10 hours per day, continuous or 24 hours per day. So based on that, you can pick the service factor also. Okay. So if not given this, if you don't know what is starting torque and what is the rating torque, so then if you want to pick the service factor CS. So then, so if they mention anything about these working conditions or working characteristics, whatever you can say, so based on that you can pick the value of the service factor. So that is the next one. And one more thing here is, okay, when coming to the dynamic load, we want to relate the Buckingham equation. Okay, and even this one also, CEB is there. Even in the table also he has given C value, he has given the E value also. I think yesterday somebody told that only C is there, E is not, small E table is not available. Maybe in the supplement he has given that also. So table 28.36. If you have data book with you, you can verify that. Okay, I'll show you that one also anyway. So here C is the deformation factor and E is the summation of errors. Okay, so even these formulas are also he has given in the data book. These formulas are also given, K value, everything is given. You can refer the data what I posted in that WhatsApp group. So you can refer that. And also one more point here is, in this he has given one more point. Okay, while calculating P effective, here the CV value. So like somebody is told, so CV value is given 3 plus V by 3. He has given like this, CV is equal to 3 plus V by 3 when velocity is less than 10 meter per second. V less than 10 meter per second. And also for a commercially cut gauge, like that is given. V less than 20, it is 6 plus V by 6 for carefully cut gauge. And V greater than 20, it is Okay, so from my end there is a power interruption. Anyway, it is resumed back. Okay, so we'll see that now. So I want to share it now. Still only 20 members have joined the class, but if I look at the end of the class, if I see the attendance, all are uploading the attendance sheet. I don't know without attending the class how you are uploading the attendance. That is without you are taking somebody's written information and you are uploading it. So if you do like that, it is going to be harmful to you only. So it is not useful to you if you do like that. That is up to you. ఇంకా చిన్నపిల్లలేం కాదు అని చెప్పడానికి. Okay, right. So here I think I am audible, right?
Sir, audible, sir.
Right. So okay, coming to the CV. So in the data book we are discussing about this. In the data book he has given 3 instead of 3 by 3 plus V, he has given it as 3 plus V divided by 3. And what he did is he has given it in a reverse manner. So our limits same less than 10 meter per second aithe 3 plus V by 3, less than 20 meter per second aithe 6 plus V by 6, and greater than 20 aithe 5.5 plus square root of V divided by 5.5. Even for non-metals it is 1 plus V by 1 plus 0.25 V, like that he has given. But what we consider while solving the problems is we consider in the opposite way. So only thing what you have to do is you have to do it in a reverse way. So that means if your CV is like this, or okay, what it is, anyway we are going to follow the data book in the examination. So what you do is don't take the CV in the denominator. So you take your fee effective is nothing but now onwards you take CS into CV into PT. You take your P effective as CS into CV into PT. Then you follow these formulas to calculate CV. Right? So that is the one more thing what we need to remember, or what is the modification we consider. Then coming to the here the K values. So in some problems we directly use the relation, that is K is equal to how this K is related to your BHN, that is for steels I already said it is K is equal to 0.16 BHN divided by 100 whole square. So ఇది గుర్తుపెట్టుకోండి అని చెప్పాను నేను, but it's not required, so no need to remember this also. So he has in the data book he has given some relations, so using that relations also you can solve it very easily. Okay, yes, I am talking about this K value or this K value. If I take you to the table what is provided as the your supplement, yes, here this one I think, yes. See here instead of K he has taken it as KW. This W stands for wear only, so this K factor comes in the wear load only, so that's why they are taking it as KW. Don't matter, doesn't matter, so whether it is K or KW. Okay, if you refer the notations, I think he has not provided the notations now with this, but you can take it as a wear factor KW. For that he has given one table also. What is the value of sigma E and its corresponding KW value, or else with this formula also you can calculate the BHN if you want to calculate the surface hardness required for the gear tooth. So what you have to do is, so this our formula for KW what he has given here is KW is equal to sigma E square sin alpha divided by 1.4 multiplied by 1 by E1 plus 1 by E2. So this is the formula he has given. So in this what we do is we have an equation for this. So to compute the BHN, so we have SW formula is there. What is the SW formula? SW is equal to P into Q into dp dash or d dash. You can take, if you follow pinion, it is dp dash. If you follow gear, that is, if gear is weaker, it is dg dash into k. So first what you have to do is, from this equation, what you have to do is you calculate what is k or kw. If you use kw here, you can use kw here also. So you know the sw. So from this equation, you can find out what is kw value. So then take that kw value and substitute here. So left side of this equation, you can substitute for kw. So what you have to do is you have to calculate what is this sigma e, surface entrance limit. He has mentioned that one as surface entrance limit. You need to calculate. So for that, in the problem data, they will give you the alpha value. That is, the pressure angle is obviously given. E1 and E2 are the Young's moduli of the both pinion and gear materials. So for E1 and E2, you have a data. So Young's modulus data is given in the data book. So if you refer the data book, you can find the E1, E2 values. You can substitute it. So that means in this entire equation, only sigma E is the unknown. So you can calculate sigma E. Suppose if both gear and pinion made of same material, your E1 is equal to E2. E1 is equal to E2. Both are made of same material means both will have same Young's modulus. So, and also if they are made of steel, let us say, if they are made of steel, you can take 2 into 10 power 5 approximate value, 2 into 10 power 5 Newton per mm square. So, you know, for a steel, it is around this 2 into 10 power 5 Newton per mm square. You can take it, you can refer the data book, you will get these values, or else exact value also available, you can take according to that. So, from the data book, in the middle properties, it will be there. So then using this, I can calculate sigma E. Once I know the sigma E, then there is a relation for sigma E and bending BHN also as given in this table. So that is, your sigma E is nothing but 2.8 times BHN minus 70. It should be expressed in Newton per mm square. That is important thing. So always the units for your sigma E should be Newton per mm square only. So that means here you need to substitute E1 and E2 in terms of Newton per mm square only. That's why I said it is 2 into 10 power 5 Newton per mm square. So now with this relation, if you know sigma E, so then you can calculate the BHN. So this is another kind of workaround solution to find out how you can find the BHN. If you know that relation, that is 0.16, your K is nothing but, if you substitute all those things here for the material, if you refer that particular table, what is the table he has given? Last table, I think I have not shared, I shared that one also. Table 28.37 he has given. So if you know sigma E, so let us say first 150 BHN, he has given sigma E as 342. If you substitute 342 for sigma E here, 342, then what you will get? 340. If I rearrange this, that means I want to relate BHN to the K. So you can relate using this also. Or else, okay, no need to do that reverse engineering. So straight away use this formula to calculate the BHN. So that means use this one to calculate. From this, you just calculate KW. Use this relation. Use the KW value here. From that, find out what is sigma E. Once you know the sigma E, use this relation to find out the what is BHN. Okay, so this is the another point I want to discuss. Then next one is, okay, this one, dynamic factor C. We will call this one as deformation factor also, dynamic factor or deformation factor, which is expressed in Newton per mm only. Then you have E is also there, that should be expressed. So here he has taken it as the C value is in terms of E. So suppose if I take 20-degree full depth gear or pinion made of steel, then this value C is equal to 11,860 into E. In our formula while discussing, we are taking it as C into B into E, but he has given the formula. That formula is nothing but only I shared that one also with you, so you can refer that. He has given only CB. So that means this E is included in the C itself in the data book. So you can, if you see that E is included here also. So that means they are one and same only. But only thing is he has given a different way. So you have to take this value. Then to find this total actual C value, you should know what is E value also. For that also he has given this table, expected error in the tooth profile in mm. But the thing here is, in our problem, he has given a grade wise, but he has not mentioned anything about a grade here. So what he mentioned is only a commercial gears with first class or carefully cut gears or precision gears. That means if you move in this direction, the error will decrease. So you can see that here 0.05, and remember here the units are mm. But while substituting, you need to substitute this one in meters. So that also be careful with that. So remember that. So here 0.05, 0.025, 0.0125 means the error is decreasing means, so the precision of gears is increasing. That means the tooth profile roughness is decreasing if you go like this. So first we'll choose this one. With this, if your design is satisfactory, we will say it's okay, because these are the commercially used gears. Generally, we'll go for the commercially. Whenever if you choose an application, you will take the commercially available one. If that is not available, then we'll go for the next one. So this is the first choice. You can say this is the second choice, and this is the third choice. Like that, you can do it. So now with this, so since he has provided these values, you can solve that particular problem what we discussed in the yesterday's class also. Okay, so I think these are the things which are sufficient. So in addition to that, he has given a ratio factor formula, Q formula, everything is there in the data. Whatever I give, even the formulas are also there. SB is there. So instead of SB, he is calling it as FB. That is the only difference. FD is also there. Dynamic load formula is also there. He has given. Even Buckingham's equation is also given. So everything is there in those two sheets what I shared. So now using those formulas and those data, you can solve the problems. Okay. Now what we'll do is we'll revisit those problems and we'll try to use this data and we will try to solve that particular problem. So now coming to the first problem. In this problem, I think same thing what we have taken here. So you have to pick the value. This one what we said is here, this one the minimum number of teeth is 20 degrees, pressure angle is 18, and we said here. So from Lewis form factor is 20, for 20 degree full depth 18 degrees, 18 number of teeth for 20 degree pressure angle. So it is going to be 0.308. So that you can take that straight away from the table. So what I shown in the beginning, the first table. If you refer this table, I'll tell you the table number. I think you have this data, 28.33. So in the table number 28.33, straight away you have for 18 number of teeth, the Lewis form factor is 3.08. So that means no issue with that. So straight away you can pick it. So earlier we discussed about some workaround solution for this, but here no need. So since they are providing these tables, that from table number 28.33, that is form factor Y in Lewis equation. So for a 18 number of teeth, 20 degree full depth teeth, Y is given as 0.308. You can use it. So then this is anyway, this data is given in the problem. Right away you can take CS. And here, this one is what you have to do is, the problem CV will be like I already mentioned, it is in a reverse way, 3 plus V by 3. So that means here you will get 8 by 3. So like I said, while calculating the effective load, you need to take the CV in the numerator. So like that you need to do that. So that you have to do that. So that means here in this formula here, if you take 3 by 8, it will come here. If you take 8 by 3, it will come here. So you have to, if you write this one as 8 by 3, even this will also come in the numerator. So that means your CV won't come here, CV will come here. So just remember that. So with that, but you are going to get the same answer only. Okay, so then, okay, this is okay. This table is there. The first preference, second preference, table is there in your data book. If as the first preference, you can take 5 as a module. Then you can calculate all those things. Then this we are not going to use any data from the data book to check the design. So these are already available things only. Again, here the CV, it is in a reverse way. So you have to take 1 by year. So if you use that particular problem. Or else, like I said here, you can write your P effective is nothing but CS into CV into PT. In fact, if you refer the tables what I given to you, he has mentioned that also. So where design tangential force along with the dynamic effect, PD is equal to P into KS into CV. KS is service factor he has taken, CV is the velocity factor. Like that he has given also. But still he has given some V also. I don't know why he has given a V. Okay, P by V he has given. P by V is nothing but your PT only. So you can use that formula also. So straight away you can use FD is nothing but P effective. In his FD he has given FD is given as P into the P means it is power. P means power here. KS is service factor. Of course, we are using CS. You can use the KS notation, no problem. CV divided by V. So with this, you will get this effective load. So in that case, CV comes in the numerator. You can clearly see that CS CV. This P by V is nothing but your FT only, PT only, or FT or PT, whatever you call it. P by V. So you will get all those things, and then you will get the effective load. Once you get that, then bending strength you can calculate. So that is straightforward only. So we already taken the Y value. Remaining things are you will get from the problem data only. So then you can easily done that. Then factor of safety is going to be like this. So up to this point there is no issue. Then coming to the next part of the question. So surface hardness here. So this is same, the same formula he has given in the data book. Even this is also same. But here what I said earlier, we have taken that K is equal to 0.16 into BHN by 100 square. So instead of taking this, I'll keep this one as K itself or KW. So now I'll calculate this one. KW is equal to this one that or else I'll write this SW in terms of KW. So that means 50 into 1.6 into 90 into KW. Instead of writing this one, I'll keep this one as KW itself. Then I'll try to find out the effective load and I'll equate this one to the effective load. So P effective into Fs is nothing but our Fs, SW. From this you will get KW value. So here this one I want, instead of taking this, I'll take this entire equation here and I'll substitute that here. So now what I want to do is I want you solve this one now. So if you solve this, then you will get some idea how you get it. So now what you have to do is here you don't take this. Instead of taking like this, you take this one as K itself or K, KW, whatever you want. So then here in this P effective here, whatever you have here you have to substitute this 50 into 1.6 into 90 into KW. So that's what you need to do. 50 into 1.6 into 90 KW. So now from this solve for the KW value. So what is KW got? It is now you tell me. $50 into 1.6 into 90 into KW is equal to your P effective into factor of safety. So from this we can calculate KW value. So you tell me what is the KW value. Anybody has done it? ఉన్నారా క్లాస్లో? ఎవడో వాళ్ళకడు. ఎరా రోల్ నెంబర్ 3 ఉన్నావా క్లాస్లో?
1.50 వచ్చింది సార్.
1.502 ఉందనా?
502. Yes, sir.
Okay, so you got KW as 1.502. Right, so now 1.502. Now we'll use the formula for KW in the just now I shown in the data book to you. So that is KW is equal to sigma E square sin alpha divided by 1.4 into 1 by E1. So since E problem lo both are made of same material, so you get 1 by E1 plus 1 by E2 is nothing but 2 by E only. So ఆ ఫార్ములా ఇచ్చాడు 1 by E1 1 by E2 అని ఇచ్చాడు. E1 is equal to E2 కాబట్టి you will get it as 2 by E. సో ఈ ఫార్ములాలో ఇప్పుడు KW is 1.502 ఉంది మనకి. I'll substitute that is equal to sigma E square which is unknown, sigma E sin pressure angle వచ్చేసి 20 degrees ఇచ్చాడు. You take sin 20 degrees divided by 1.4 into 2 divided by, like I said, you take it as, if you refer the data book, exact value is 205,000 or 2.05 into 10 cube. Exact value is this one. If you don't know exact value, you take it as 250s. Like that also you can take 2 into 10 4 also you can take it. So let us take exact value. So because you have a data book with you, you can refer that. He has given 30C8. For the 30C8 it is around 205,000 or 207,000 like that. So now with this you calculate what is your sigma E. So now you tell me what is the sigma E value. You'll get it as, calculate cheste you'll get it as 793.84 Newton per mm square. You check whether this calculation is correct or not. So once you got the sigma E, then you have a relation between sigma E and BHN. Sigma E is equal to 2.8. That is also there in the data book. నేను ఎక్కడి నుంచో తీసి రాయట్లేదు ఈ రిలేషన్ అన్ని. డేటా బుక్ మీకు ఇచ్చే సప్లిమెంట్లో ఉంటుంది. నిన్న నేను షేర్ చేసిన షీట్లో ఉంటాయి ఈ రిలేషన్లు అన్ని. -70. సిగ్మా E is equal to 2.8 BHN minus 70. సో దీని నుంచి BHN ఫార్ములా ఏంటి? BHN is equal to sigma E plus 70 divided by 2.8. So sigma E already 793.84 వచ్చింది ఇక్కడ. అది సబ్స్టిట్యూట్ చేసి క్యాలిక్యులేట్ చేస్తే BHN ఎంత వచ్చిందో చెప్పండి.
308 వచ్చింది సార్.
308.51 వచ్చింది. సో అంటే you can round it up to 310. So that is the answer. So like this you can solve this. సో ఇలా కాకుండా ఎర్లియర్ మనం సాల్వ్ చేసిన ప్రాసెస్లో మనం సాల్వ్ చేసే ఆన్సర్ ఎంత వచ్చింది? అదే వచ్చింది చూడండి, 306.39 వచ్చింది, విచ్ ఈజ్ ఈక్వల్ టు 310. సో ఇది కూడా మనం రౌండ్ అప్, యూ కెన్ రౌండ్ ఇట్ అప్ టు 310. సో ఇట్ విల్ వర్క్. సో డేటా బుక్లో ఇచ్చిన ఫార్ములాస్ ఉపయోగించి యూ కెన్ try and you can solve it also, right? Okay, so this is about this first problem. So second problem lo em vachino chuddam okasari data. So second problem I think straight forward 20th ki 50th ki. So pressure angle ఎంత ఇచ్చాడు నీకు ఈ ఫార్ములాలో? 20 degrees full depth అని ఇచ్చాడు. సో you have to take 20 కి 50 కి ఈ 0.32 0.408. సో మీరు ఆల్రెడీ ఐ థింక్ మీ సార్ సాల్వ్ చేయొచ్చు ఈ ప్రాబ్లం. నేను కొంతమంది సాల్వ్ చేశారు. ఈ వాల్యూ మటుకు వాళ్ళకి 0.408 కాబట్టి మనం ఏదో టేబుల్ ఉపయోగించి చేసాం కాబట్టి దాంట్లో వేరే 0.5 అంత వచ్చిందని చెప్పారు వాళ్ళు. నౌ ఇఫ్ యూ యూజ్ దిస్ టేబుల్ యూ చెక్ దట్ ఎగ్జాక్ట్లీ యూ ఆర్ గెటింగ్ దోస్ వాల్యూస్ ఆర్ నాట్. సో 20కి ఆల్రెడీ ఓకే. సో ఫర్ 20 నెంబర్ ఆఫ్ 0.32 ఉంది ఇంకా టేబుల్లో. 28.33 టేబుల్. అట్లానే నెక్స్ట్ 50th కి ఎంత ఉంది? 0.346 కాదు, 0.408. సో ఈ రెండు వాల్యూసే ఉన్నాయి. సో లెట్ మీ షో యూ ద టేబుల్ దెన్. Okay, so here this is the table you have to choose. In this table for 20 degrees full depth, so you have to look at in this column and the number of teeth is 20. So the value of y is 0.32. Then for 50 teeth, so this is the column row corresponding to 50 teeth. For 20 degree full depth is the value is 0.408. So straight away ఆ ప్రాబ్లం ఏదైతే మనం డిస్కస్ చేసామో అదని ఆ వాల్యూ డైరెక్ట్గా తీసేసుకోవచ్చు ఈ టేబుల్. ఇఫ్ యూ రిఫర్ దిస్ టేబుల్. సో ఈ టేబుల్ కాకుండా అంతకుముందు వాడిన టేబుల్ వాడద్దు మీరు. సో ఇది పాయింట్ కాసాలో పెట్టి డివైడ్ చేసి చేసాం కదా, డోంట్ గో ఫర్ దట్. సో యూజ్ దిస్ టేబుల్ నౌ, ఎగ్జాక్ట్లీ విల్ గెట్ ద సేమ్ వాల్యూస్. సో యూ వోంట్ గెట్ ఎనీ డిఫరెన్స్ ఇన్ ద సొల్యూషన్ ఆల్సో. దెన్ దిస్ ఈజ్ గోయింగ్ టు బి సేమ్ ఎనీవే. వీఆర్ నాట్ sigma b is comes from this SUD value. So this దీనిలో పెద్ద చేంజ్ ఏమి ఉండదు. సో యూ విల్ గెట్ ద సేమ్ వాల్యూస్ ఆల్ దీస్ థింగ్స్. ఈవెన్ these things are also it is not depending upon the data book data. Okay, anyway this one CV like we discussed is in the data book he has given in a reverse way. So you need to reverse this one also in the problems. So here also CV instead of here you have to take CV here, then you can calculate the module, you will get the same value. Then coming to this, okay, this is once you decided this is okay, fine, everything is fine, this is also fine. Okay, so no change. Again here you have to take 6 plus in the data book he has given it as 6 plus V divided by 6. So you reverse it and apply it to the effective load. So then you will get the same value. So this is straightforward only, no change. You will get this stack class as 1.5 and 76. So as long as this problem is concerned and straight away if you use the table you will get the same answers with this one. Then coming to the third problem here. So again in the third problem, first thing here the thing is only about concern is about this one. He mentioned grade of machining 8 like that he mentioned. So for this kind of thing we don't have any data in the data book. So what we'll do is we'll use a commercially used gauge for this and we'll try to see what is the solution you are going to get with that. Okay, so this is the same. No, it is not dependent upon your data from the data book. Now here this one for 90 number of teeth we are taking it as 0.314 Lewis form factor. How we got that? Again if I take back you to the table like I said, you need to average the values. What you have to do is in this you can see it here For 80 teeth, 0.308 he has given. For 20 teeth, he has given it as 0.32. So for 19 teeth, what you have to do is, you need to average. So that means you have to take average of these two. That is 0.308, 0.32 divided by 2. 0.308 plus 0.302 divided by 2. You are going to get the exact value what I have taken there. So this is problem number 1. I'll go for 3. For 19 teeth, if you take the average, you will get 0.314 only. 0.308, 0.32 average, 0.314. 8 plus 2, 28. 28 by divided by 2 is nothing but 14 only. So you will get 0.314. Exactly, you will get this value. So issue with this one is also resolved now. Anyway, this is same. Even this is also same, straightforward. You will get the same values. Then this is same. No, it won't depend upon data book. Even this also don't depend upon data book. Here you have to take in a reverse manner. You remember that. Again, if you take in a reverse way, here you have to take CV in the numerator. That is the thing you need to remember. So you get the same values with that. Then coming to the surface hardness, again here SW will calculate. So from the SW, we'll try to calculate what is KW, this K value. Instead of writing this one as 0.61 PHN by 100. So now, okay, so instead of discussing that, now you try to solve this and you tell me what is the value of KW, and also I want BHN here. So like what I discussed in the procedure, first problem already in Japan. Use those formulas and tell me what is the BHN for this one now. Here you have to take only KW. But here your pinion and gear made of different materials. So that's what he has given in the problem, I think. So then your E1 and E2 are different. So you need to pick E1 and E2 from the data book, then you need to do it. So if you practice it, then only you can understand it. Then do that now. So do that, and if you have any difficulty, then I will discuss it. So I think still we have 5 more minutes time. So in that time, if it is possible, you can solve it. Otherwise, we will discuss in the afternoon class also. I think I already placed the attendance sheet. You respond to the attendance sheet. So then, if you have time, you solve it. Otherwise, we'll discuss in the afternoon class. Huh? Emma?
అటెండెన్స్ డైరెక్ట్ తీసుకోండి సార్ వాళ్ళ క్లాస్కి.
ఏంటది?
అటెండెన్స్ సార్
అటెండెన్స్
డైరెక్ట్గా తీసుకోండి సార్.
ఏంటి అర్థం కాల చెప్పింది. అటెండెన్స్
డైరెక్ట్గా అంత తీసుకోమంటున్నాడు సార్.
డైరెక్ట్గా ఎందుకు ఏ మ్యానిపులేట్ చేస్తారనా?
కాదు సార్,
ఆ,
మొన్న చెప్పిన ప్రాబ్లమ్స్ డిస్కస్ చేశాం కదా సార్, అందుకని.
ఏమైంది దాన్ని అప్లోడ్ చేయి, ఏమన్నాడా? నువ్వు ఏదైతే నోట్ చేసావో దాన్ని అప్లోడ్ చేయరా?
ఓకే సార్.
సార్ ఆఫ్టర్నూన్ ఏ అవ్వదు సార్,
ఏడా
ఎన్నో అవ్వదు సార్ ఆఫ్టర్నూన్.
అర్థం కాల.
ఏ అవర్ సార్ ఆఫ్టర్నూన్? ఏ పీరియడ్ సార్ మధ్యాహ్నం?
ఓఆర్ రా, 5th అవర్.
ఓకే సార్.
సార్ E1 E2 ఎలా తీసుకోవాలి సార్?
డేటా బుక్ ఉంటుంది కదా, మెకానికల్ ప్రాపర్టీస్ ఆఫ్ మెటీరియల్స్ అండ్ టేబుల్స్ ఉంటాయి చూడు, దాంట్లో ఫస్ట్ స్టార్టింగ్లో ఉంటాయి చూడు. నీకు మెటీరియల్ స్పెసిఫై చేసాడా ప్రాబ్లం డేటాలో? గేర్కి ఏం మెటీరియల్ అనో దీనికి ఏం మెటీరియల్ అని స్పెసిఫై చేసాడా? ప్రాబ్లంలో ఇచ్చాడు కదా. గేర్ ఈజ్ మేడ్ ఆఫ్ 48. రెండు ఒకటే, ద పినియన్ యాజ్ వెల్ యాజ్ గేర్ ఈజ్ మేడ్ ఆఫ్ 48 అని ఇచ్చాడు. రెండింటికి ఒకటే ఇచ్చాడు కాబట్టి ఒక 2E/E తీసుకుంటే సరిపోతుంది. నేను డిఫరెంట్ అనుకున్నా, బట్ ఇయర్ హాజ్ గివెన్ ద సేమ్ వాల్యూ. సో రెండింటికి సేమ్ వాల్యూ కాబట్టి ఒక వి. సో స్టీలే కాబట్టి జనరల్గా స్టీల్కి ఎంత ఉంటుంది ఇందాక చెప్పే కదా వాల్యూ, యూ కెన్ యూజ్ దట్ వాల్యూ. సో 205,000 or 205 millions, what you can say. You can use that data, you can solve it. Anyway, time అయిపోయింది కాబట్టి we'll discuss in the afternoon class. So, okay. So I'm stopping the recording and I'll close the class.